And this is an example of, energy consumption benchmark by per available room, per occupied room, per square foot area. You can put them into two categories: mid-scale properties, luxury properties, or lower mid-scale properties. You can do that slice, and this data is available on a real-time basis. So you can actually provide us the room night data through a API interface. I can pull the data from your system. You can manually upload the room night sold data to my system, or I can give you the energy data and you can correlate it at your end in real time, right? So either ways is easily doable. This is an example. These are the properties on. So each row is a property, right? And what you see is the time of the hour of the day, and you see the temperature. So this is temperature of all their lobbies on a single screen, and you see that the lighter areas are towards colder side, and the dark green areas are towards the higher side. So over a time, they see that this whole heat map was becoming more homogeneous in terms of temperatures that are maintained. This is an example of a cold storage, where you can actually look at the health of a refrigeration unit. And what we do is simple intervention, deploy a temperature sensor within the cold storage, which is again a battery powered wireless sensor. We can deploy energy meter on the power supply, and energy meters are very inexpensive, right? I mean, they're easy to deploy. And what it tells us is the current, right? So you see two cold storages here. One is a black line, which is and you see the compressor cycle, duty cycle, right? The temperature is achieved, the compressor shuts down, the temperature is out of the range, compressor switches on, right? And that's how a healthy compressor operates, right? But here you see another compressor, which is mostly on all the time, right? And that's where the problem is. It is consuming, twice the energy than it should. Otherwise, if it was duty cycling, like the other compressor, it was consuming probably 40 to 50% of the energy. And because it's on for a much longer duration, it is likely to break down, right? So what we would do is that, we will not simply expect somebody to analyze this data. Our systems are going to automatically analyze this data and create a ticket in the system. And it'll say cold storage 2 at this particular property, the compressor is continuously running, right? I mean, we will simplify it to that level. So I think that's the power of data and running algorithms on that data. These are the examples of ticketing, right? As I said, you can define benchmarks. If it's a high energy consumption per occupied room, high temperature in certain areas, it could be a very simple ticket. It could be a very advanced ticket, like a cold room, compressor continuously running alert, or a high approach issue of a cooling tower. All of those things can be created as tickets in the system. And our system has a workflow which actually allows you to close the ticket. You can put it on hold. You can you can assign it to someone. You can put it on in a stop mode or a hold mode, because you ordered a material. You don't want the ticket to sort of escalate it to someone else because you already ordered a material. So I think there are capabilities in the system where you can assign a ticket to someone or change its status. So all of those things are easily possible, and it's very, very data driven. So if you forcefully close a ticket and the data is not right, the system is going to reopen that ticket, right? And the other way around, if you have fixed something, you don't need to close the ticket. If the data is fine, the system will automatically close the ticket. So I think that's how we have architected the system, and that defines real closures overall. This is a simple example of electrical health, where you are actually measuring current unbalances on circuits. You are measuring your voltage compliance. You're measuring your power factor. And if something goes out of the range, again, you can actually, raise an alarm. This is an example of refrigeration temperature compliance. And again, as I've given you the example that, the percentage compliance defines that what percentage of the time that you are actually staying within the range, right? And you can actually compare different cold storages, right? And you can see a wide distribution. And once you start addressing the tickets, so the tickets can be raised for low temperature compliance also. So if you say it's less than 60%, raise me a ticket, less than 80%, raise me a ticket. And once you start fixing those problems, and there could be many problems which at the site. It could be a compressor, a gas leakage issue. There could be a door opening issue that, the cold storage's doors are kept open. All of those things, come to highlight once you start monitoring the data.